This lesson is about horizontal and vertical reflections. Let's jump down to the interactive panel. So, there's one small variation with transformations that we haven't covered yet. There's only 4 transformations we can make to a sine function. First one is putting something at the front, timesing by something, and putting something at the end, adding or subtracting something. And then on the input side, like within here, we can times by something and we can add or subtract something. So that's that. The only small thing that changes here, which we mentioned a little bit in one of the lessons, but what if one of these things is negative? And more so like the H and the K, if it's negative, it's not a big deal, but it can be a little bit tricky if the A is negative or if the B is negative, like that, okay? So that's what we're going to be looking at in this lesson. First, let's get our points going here. So let's make 5 points, and then I want you to pause the video and try and fill in what they should be. If we're going from 0 to 2 pi, what would the key points be? Okay, pause the video now. Now I'm going to do it. So we want 0 here, 2 pi over here, and then we want like the major points. So pi is going to be in the middle, and then pi on 2, etc. Right? And so for sine, we're going to get 0 there, and then 1, then 0, and then this will be 3 pi on 2, and this will be -1. That'll be 0. Let's press save to save the points. All right, and then sure, let's graph it. So that's what the default looks like. Now, what if we put a negative number or something negative with the, no, we'll do it with the output first. We'll do it with this one. So negative out the front. This is like having a -1 for A instead of just the default of 1. So what if we have negative here? Well, thinking about inputs and outputs, sine is still going to do the same thing. So let me pull up that previous lesson. So remember sine, let's open everything up. If we press play, wow, that's slow. Let me speed up a bit. Okay, cool. So remember that sine, its output, so the thing that comes up over here, it's just represented by how big this purple line is. And so it's always just going to go between 1 and -1. Now we might transform it after with A and K, but by default it only goes from 1 to -1. So if we then, let's pause that, if we then go and put a negative in front of that, it just means all the outputs are now the negative of what they were before. So if it's 0, then now it's actually -0, which is still 0. But looking at this 1, it's not a 1 anymore, it's going to be a -1. When you put in pi on 2, you get a 1, but then you make it negative, so it's going to be -1. And then 0 will stay 0. If you put in 3 pi on 2, normally you get -1, but if you put a negative in front, now you've got negative, which is just positive. So it actually goes like that. So let's save these points. And so see how it just kind of swaps. And then let's run the frog and see if we got it right. Nice. So basically it just flips it. And that's why this lesson is called reflections, because you can think of it like it reflects. Let me center it again. It just reflects itself. Okay? Let's maybe, what should we do now? Let's look at it on Desmos. So if we have our sine there, and then let's do sine but make it negative. And so see how it's like a reflection. Imagine this is like a mirror or like some water, and maybe these are like mountains, and see how you're going to get a reflection of those mountains in the water. Or if you're looking at a mirror, it just reflects into the mirror. That's really it. If we make it like -3, and then we have a 3 here, it's you get the stretch that comes from timesing something out the front, and then you also get the flip that comes from the negative. So we were talking about how you can have four things happening. So a sine bx minus h plus k. And so 1, 2, 3, 4 things to consider. If there's a negative in the front of any of these, or like rather if b or a are negative, that's kind of its own transformation. So you could technically say there's six possible transformations. But the negative that's the reflection transformation is part of the A and B. Cool. Let's have a look at, we can have a look at what happens on this part if we make this a -1. And so that's the reflection happening. When the actual output of the sine is going like this, the final output, once we make it negative, does the opposite. So 0, they line up, but the ones are negative ones and the negative ones are ones. Cool? Cool. Let's reset that to be a 1. Now let's look at the only other reflection, which is instead of, let's clear this one. Yep. And then let's go to here. And then if we have a negative on the x this time, then what happens? So what we did on those original horizontal translation things we were doing is saying, okay, if I want to do sine of pi on 2 to get a 1, then let me draw this out actually. So if I have sine of x, and that gives me a 1, for example, then whatever I put into, and that came from doing sine of pi on 2. Then whatever I put into my sine part here, this needs to equal pi on 2. So if I have, instead of x, I have negative x, then that means negative x needs to equal pi on 2 for us to still get our 1 that we're looking for. And so, how do we solve for what x needs to be? Well, we can times both sides by -1, or you could just make each side negative. And so those negatives will cancel, and then you can see that what happens is we need to times by a -1 to the original thing we had to counteract the negative. And so you just get negative pi on 2. So this one here will be a negative pi on 2. The 0 we can skip because -0 is just 0. And then this pi here would need to be negative pi. That way when you actually put it in, the negatives will cancel each other out. And then here, negative, and then here, negative, and then nothing will change with the y. Let's press save and see, look what happens. They get reflected. So this guy was here, and now he's been reflected to go there. This guy was at pi, now he's been reflected across the y-axis, is like the mirror, and now he's over here. This guy was over here, now he's reflected over there. This guy was here, now he's reflected over there. If we graph it right now, it won't work because the frog currently is set to only go from 0 to 2 pi, but we can change it to be -2 pi. And then we can leave that as 2 pi, that's fine. Let's close this and run it, I think it should work. We'll hide the table. And yeah, there we go. And so we can see everything's just been reflected. Having a look at it on Desmos, if we get rid of that, we just have our sine, and then the original can be the red one, and then let's put a negative there. This one actually looks kind of the same as when we flipped it by putting a negative in the front. But in this case, focus more on how the original point here of like pi on 2 and 1, that's been reflected over to here, which is now there. And then this pi gets reflected over to negative pi. This one down here gets reflected over to here, and the 2 pi gets reflected over to here. Rather than, if we are looking at a vertical reflection, again, it looks pretty similar, but in this case, what's actually happening is this point gets reflected down to here. This point stays where it is. This point gets reflected down to here. That one stays. This one gets reflected down to here. And on the negative side, same kind of thing. This one was a negative originally on the red line, and then it gets reflected up to there. This one gets reflected, this one gets reflected down to there. This one gets reflected up to there. It's just a coincidence that they happen to kind of look similar. I think maybe it gets more obvious if you do something like 2 sine x and then negative 2 sine x. You get this. Whereas if you put the 2's on the inside, you have the 2 there, then the negative 2 here. Now it looks a bit different. You still could see how this could be like a vertical reflection, but you don't have that. There we go. You don't have the amplitude change as well. Okay, so there's some coincidences that happen, but we want to focus on reflecting across the y-axis as the mirror if we're doing a translation like that. And if we're doing a translation, like a reflection on the y-axis, then the x-axis is the mirror. Okay? Might take a little bit to get your head around, but that's how I would think about it. The last thing is, let's put it into here and see what's happening. And we'll press play and see how instead of the angle getting more positive, as we go around, like we're going around and getting more and more and more radians, you actually get a flip and it actually kind of goes backwards instead. And so that's how we get the behavior of the reflection. And so see, that also causes this sort of the vertical reflection that we were seeing, because by going backwards with our angle when it comes to sine, you do get that flip. And so when this guy is positive going up, this guy actually went down. So let's watch it. We'll just go like this. When we're going this way, this guy is actually going down and negative. And then we hit our max of -1, it's actually there. But that's not caused by us flipping using the A. It's caused by us flipping the angle, and it just happens to also cause this to flip. Perfect. That's all there is for this one. Feel free to mess around with this. You could also look at like, what if you do a -2x if you wanted to using this, but that's all I wanted to really cover. And now you can go on to the practice questions, which is similar to the last ones, but this time we're including negatives here. Negatives out the front, negatives on the inside, and then there's one here that includes a negative for both of them. And then we have a challenge question as well. So give them a go. Don't forget there's a video explanation. When you finish, tick off the lesson and move on to the next one.